All right, class, so I'm going to continue where I left off before my internet went down. And so I believe the question was, do we still have to say that, hey, you know, since the vertex is at 3, 0, right? You know, do I still have to say reflection across the y-axis? And let me show you that, you know, it ends up being the same graph. So here's my absolute value of x. Right, this is my parent function, right, f of x. And if I were to reflect it across the y, right, just think about it, reflect over y. Well, think about it. If you reflect this graph over the y-axis, you end up having the exact same graph, right? And so that's why absolute value and parabolas, especially if they're symmetric to the y-axis, are a little bit tricky. And then after you reflect it across the y, of course, you can go 3 units to the right, you know, roughly something like this. Okay, so you have to basically state that, yeah, it's a reflection across the y, 3 units to the right. Even if you don't say it, you know, you still end up with the same graph. But I want you guys on a quiz or test to state that, because there's a negative here, you know, state that this means reflection over the y. Okay, but if you look at the graph, right, reflected over the y, you end up with the same graph. All right, so moving on to number 4. Over here, we have a square root function. And we're trying to graph g and h. Okay, so even though in the problem it says we're going to track 1 point, I'm actually going to track 2 points on this one. Okay, so for f of x, we'll say x comma f, right? 0 comma 0 is our starting point, and then maybe I will just use the value of 4. Okay, so 4, I'm going to get. If I plug in 4, I'm going to get 2. Square root of 4 is 2. Okay, so if you remember your square root function, let me draw some tick marks here. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 6, 7. 4, 5, 6, 7. Okay, so 0 comma 0 is our starting point. And then 1, 2, 3, 4, comma 2. Your graph looks roughly something like this. Okay, so there's my f of x. And for g, right, if I ask you, what does the graph of g look like? What does this do? You would say, this negative means reflection over the x, right? Even though the problem doesn't say it, I'm going to just review transformations with you. And then vertical shrink, okay, vertical shrink factor of 1/2, okay, because the absolute value of a is between 0 and 1, okay, vertical shrink, or the words that I used in the notes were compression, okay, so if you want to say compression, either one of these words is fine, okay. All right, so how do I draw a graph reflection over the x? Basically, it would look something like this. And in fact, it's a little bit hard for me to show to you, but I'm just going to I want to plot some points. Okay, so x comma g. And because you have a number out here, right, all that does is impacts the y value. So I'm going to take my original x, 0 comma 4, and I'm going to keep that. But I'm going to take my y values from my f of x and multiply by negative 1/2. Okay, so if I go back to my these coordinates right here in the table, I take 0 multiplied by negative 1/2, I'm going to get 0. If I take 2 and I multiply by negative 1/2, I'm going to get negative 1. Okay, so your graph's going to look like this: 0, 0, 1, 2, 3, 4, comma, negative 1. And that is what a vertical shrink looks like. This is why I'm tracking. This is why I'm tracking 2 points, okay? So it's a little bit harder if you only track 1 point. So there's g of x, okay? So all I did was take the y values over here and multiply by negative 1/2. So anything on the outside, if you have an a value, vertical shrink, or compression factor, you take it and multiply your y values, okay? You'll see this example more in detail in the next problem. Okay, so on this one right here, on part H, you have to kind of rewrite it. And what do I mean by rewriting? Well, rewrite this as negative x plus 4 plus 2 and factor out that negative. Okay, so again, factoring out that negative. So this one, it bears worth explaining. How is this function h of x different from f of x? This means reflection over the x, right? This means reflection over the y, so x and y, 4 units to the right and then 2 units up. Okay, so that's how you would describe the transformation in words. Okay, but the tricky part is, how do I graph this, right? And again, this is why I'm tracking 2 points. Okay, so we'll call this x comma h. If you take a look right here, let's start with the x values. The way you determine what to do with the x values is you look on the inside, right? Because it's shifted 4 units to the right, typically I would add 4, right? But I also have a reflection over the y. So for the x values, what you want to do is you divide by -1 and add 4, okay? And where do you get that? Because of this negative and this shifted 4 to the right. And then what do I do with the original y values? The original y values, I multiply by -1 and add 2. Okay, so I look on the outside, right? Over here I have this negative, over here I have this +2. That determines what I do with the y values. And so I go to my original x values for my f. So my original, let me just write it here. It's 0, 0, and 4, 2. So here's 0, 0, and 4, 2. So if my x values, I divide by -1, 0 divide by -1, 0, and I add 4, I get 4. Over here, 4 divided by -1, well, that's -4. -4 plus 4 is 0. And for the y values, I multiply by -1. 0 times -1 is 0. 0 plus 2 is 2. And 2 times -1 is -2. -2 plus 2 is 0. Okay, and this is how you would graph. So 4 comma 2 is my starting point. 1, 2, 3, 4. 1, 2. And then 0, 0 is another point. So the graph will look roughly something like this. Okay, so there's my h of x. Okay, so again, right, it's like, how do you know it goes this way? Remember, it's reflected over the x and the y. So reflected over the x. Then I reflect it over the y, and then I shift it 4 units to the right, 2 units up. So the graph's going to look something like this. So by the way, this is called the starting point, right, of your graph. This is called the starting point, right? Well, at least I call it the starting point. Okay, so this last one, this h graph, is a little bit tricky. I would study it in detail. If you need to go back and replay the videos, or if you need a little bit help, you can ask me, and I'll try to explain that to you live.